Have you ever wondered why you stay grounded on Earth? It's not just by chance or magic. There's a powerful force at work. What keeps the moon orbiting our planet? Why doesn't it just drift away into the vastness of space? It's an invisible force called gravity. Gravity is everywhere. It pulls objects towards each other, giving weight to physical objects and causing them to fall to the ground when dropped. It affects everything in the universe, from the smallest particles to the largest stars. Even the tiniest atoms are influenced by gravity. It's what holds our world together. Without gravity, there would be no atmosphere, no oceans, and no life as we know it. Without gravity, we would float away into space. Imagine a world where nothing stays in place, where everything drifts aimlessly. Our planet wouldn't exist as we know it. The land, the seas, and the air we breathe are all held together by gravity. Gravity is a fundamental force of nature that shapes the cosmos. It governs the motion of planets, stars, and galaxies, creating the structure of the universe. Understanding gravity is key to unraveling the mysteries of the universe. By studying this invisible force, we can learn more about the origins and the future of everything around us. Gravity is a force of attraction between any two objects that have mass. It is one of the fundamental forces of nature, governing the motion of planets, stars, and galaxies. Without gravity, the universe as we know it would not exist. The more massive an object is, the stronger its gravitational pull. This is why planets with greater mass have a more significant influence on their moons and other objects in space. For example, the Sun's massive gravitational pull keeps the planets in our solar system in orbit around it. The closer two objects are, the stronger the attraction between them. This principle can be observed in everyday life, such as when magnets pull towards each other, or when you feel the pull of the Earth keeping you grounded. The story goes that Isaac Newton, a brilliant scientist, was sitting under an apple tree when an apple fell on his head. This seemingly simple event led him to ponder the forces at play and question why the apple fell straight down. This event sparked his curiosity and led him to discover the law of universal gravitation. Newton's groundbreaking work laid the foundation for classical mechanics and changed our understanding of the universe forever. His equations and theories continue to influence scientific thought and exploration to this day. Newton's law of universal gravitation explains how gravity works. It states that every object in the universe attracts every other object with a force. This force is directly proportional to the product of their masses. The force of gravity also decreases with distance. It is inversely proportional to the square of the distance between the centers of the objects. Newton's law provided a mathematical framework to understand this fundamental force. Gravity plays a crucial role in our daily lives. It's an invisible force that we often take for granted, yet it affects everything around us. It's the reason objects fall to the ground when we drop them. Whether it's a ball, a book, or an apple, gravity pulls them down with a consistent force. It's why water flows downhill, and why we can stand on the Earth's surface. Without gravity, rivers wouldn't flow, and mountains wouldn't stand tall. Gravity also keeps our atmosphere in place, allowing us to breathe. It holds the air close to the Earth, making life possible for all living creatures. It governs the motion of the planets around the Sun and the tides in our oceans. The gravitational pull of the Moon creates the rhythmic rise and fall of ocean tides. Gravity is essential for life as we know it. It shapes our environment, influences our weather, and even affects how we move and grow. From the smallest particles to the largest celestial bodies, gravity is the force that binds us all together. While Newton's law explained how gravity works, it didn't explain what gravity is. Albert Einstein, another brilliant physicist, proposed a revolutionary theory that went beyond Newton's classical understanding. Einstein's theory of general relativity describes gravity not as a force, but as a curvature in space-time. Imagine a bowling ball placed on a stretched-out sheet. The ball creates a dip in the sheet, much like massive objects warp the fabric of space-time. According to Einstein, objects with mass cause a distortion in space-time. This distortion is what we perceive as gravity. Objects move along the curves created by this warped space-time. This revolutionary theory explains some phenomena that Newton's law couldn't, such as the bending of light around massive objects and the slight variations in the orbits of planets. Einstein's theory provided a deeper understanding of gravity's influence on the cosmos.